Hello, everyone, and welcome to the webinar. Nice to see so many people joining in. If you don't mind, there we go. Hi. If you don't mind, let us know where you're joining in from. We always have a lot of different people joining in from different places. Very nice to see that there's already a question in the audience chat. We'll get to that in just a minute. The guys will be dealing with all the different questions as we go along, and I'll be trying to answer a few questions on the chat. Just a quick introduction to me. My name is Frederica, and I'm the community manager with GxP. I help orchestrate these webinars with our Chief Quality Officer, Jakob, who's also a co-founder of GxP, and then with Mads, as you'll be meeting shortly, who's a senior product specialist. I think you all know that we will be talking about temperature mappings today, specifically winter temperature mappings. And well, if you don't mind, please let us know where you're joining in from. It would be really nice to see the different countries you're representing. I would also just like to let you know that for the people joining in on this webinar, we're offering just a free consulting session with a product specialist that will probably be Mads. So if you need some guidance or some consulting on your upcoming mapping project or your current mapping projects, he's at your availability, and I'll send you guys a link if you could use a helping hand on this. There we go. And yeah, handing it over to you, Jakob, and you, Mads, just for a brief introduction, and let's get started.
Well, thank you very much, Frederica. We've really been looking forward to this webinar on winter mappings. It's one of the multitude of questions we get a lot regarding how should you deal with different seasonal mappings. I know there was some question in the beginning here as well. We're working with trailers, and a lot of the methodologies that we'll talk about today definitely apply to trailers. Otherwise, you're more than welcome to reach out to my colleague Mads or I, and we can we can most certainly get you started. But without much further ado, I think we'll get started with the webinar. We have some lovely people behind the screen as well, helping us to get this show on the road, so to say. But just a short introduction of who we are. I have with me my colleague Mads, who's a senior account executive here at GxP, helping a lot of our clients in finding the right solutions, both in terms of validation and constant monitoring. And myself, I'm head of quality at GxP. I've been here since the beginning. And I work with making sure that we supply the right solutions, that we have calibrated equipment, and that we have control over our processes. I have 10 years of experience in performing temperature mappings with several hundred different cases. We have all the way from small units to giant warehouses. So there's definitely a lot of the different customers we've seen with different needs. But I'll hand it over to you, Mads, in terms of giving just a short introduction of who we are as a company.
Thank you, Jakob, and nice to meet you all. If some of you have been joining in on these webinars before, you would normally see me and Jakob sitting next to each other. We are not doing that today, as I'm sitting in our US office at the moment. But yeah, to give you a brief introduction to GxP and what we do. We are a company which is obviously working around environmental compliance. We're trying to structure it around a lot of the different elements. Typically, we have mappings, we have monitoring, we have the whole validation, all these different elements, which is essentially some of the things that you guys need to have in control in order to prepare for an audit. So how can we actually combine these different elements? How can we be a company which can actually be like a one-stop solution for it, and really bridging the gap between all these different elements, because they are all related to each other, and obviously very much related to the whole audit preparation part of it. So that's a short introduction, at least, to what we do and what we work with in our day-to-day.
Great. Thank you so much, Mads. And the theme we're going to talk about today is winter mappings, and would always like to give an introduction to the mapping process and how that works. So today we'll have just a brief introduction to the mapping process, but today we'll deep dive into some of the topics that are more relevant related to winter mappings. We do know that winter is not the same all around the world, and as we have customers around the world, we're also very well aware that there are differences. But winter could also be seen as the coldest season of the year. And that's also some of the considerations that we'll go through. So we'll take a deep dive into some of the considerations that are really relevant for winter mappings, and some of the different topics that could be addressed in a winter mapping. We do have a Q&A at the end, but please feel free to ask questions at the chat. We'll try to follow along here and bring up some of those that are relevant to what we're talking about. So please give it a hit and use the chat along the way. So talking about the mapping process, one of the key elements that we often see is a bit confusing regarding where does mapping fit into the whole validation scheme. And if we have a standard V model, which is quite widely adapted, it's important to notice that the mapping or the thermal mapping studies are really a part of the qualification of the units. So that be anything from containers, temperature controlled containers, shipments, warehouses, fridges, freezers, and so forth, where we want to ensure that we have a confirmation of the performance according to our requirements. And that might be both user requirements or functional requirements. But basically, we need to ensure that if we have defined a certain set of criteria for what a temperature controlled environment should behave, or what the specifications are, we need to adapt a methodology where we can prove or document that those conditions are actually what we see in the real world. So we often like to draw it as such. So in the small diagram here, that the operational qualification is often considered as an empty study. So how does the unit or warehouse or freezer, or whatever it might be, operate under empty conditions without any sort of interference? On top of that, we'd like to build up in terms of the performance qualification. So how do these units, temperature controlled units, behave when they're under operation or under performance? So there are different methodologies that we'll discuss today in terms of how can you do that and what is really relevant towards specifically winter mappings. But the key baseline here is still that temperature mappings and for that matter also relative humidity mappings are a part of the qualification stage. It really often does not matter that much how your terminology is defined, as long as it is performed as sort of a check that the specifications can actually be upheld. So taking a look into the mapping process here, we often like to split it in three, in which we have the protocol. In the protocol, we define what is the scope of this mapping, what is the scope of the testing, which data are we hoping to achieve from the study, which specifications are we trying to fulfill. We'll also have the methodology, which is for most parts what we're going to talk about today. We'll also have which reporting do we expect. So when we have the mapping report, what kind of data and information would we like in there? And there are other items such as training requirements, documentation requirements, and so forth. Then we have the execution phase. And in the execution phase, we'll actually conduct the mapping. So we'll set up loggers. We'll do different test scenarios, as we'll also get into in just a short while. Door opening studies, power failure studies, stability studies, full and empty. There's a lot of different things to take into account there. And we'll actually gather the data that we need and we'll document that we've performed the actions. In the reporting stage, that is where we draw conclusions based on the data that we've gathered. So we'll look at the data, we'll do some data analysis, we'll do risk assessments if there are any non-conformities that happened during the mapping and whether those have had an implication to the conclusion we're about to draw. And then we'll report on the findings as to compare those to the requirements. And that's really one of the key elements we often see in our experience, that is lagging just a bit is that a clear understanding of the requirements is needed both for doing the protocol, but also for doing the reporting. That's really one of the key elements. That's a very, very rough introduction to mappings in general. We do have a lot of other recorded webinars if you're more interested in deep diving into how to write a protocol, how to write a report. But today, we'll try to focus on the winter mapping. And one of the key elements, one of the questions we get is, why would you call it a winter mapping? Well, the baseline is basically that for a lot of the standards out there, and when I say standards, we have the ISPE standard for temperature controlled environments, and we have WHO. We do have a series of other standards for how to perform temperature mapping, as well as a lot of the GxP requirements basically state that you need to perform seasonal mappings. With that being said, there's also a promotion of the risk-based approach. So what that means in terms of whether you need to perform a summer and a winter mapping, for example, is that you need to perform a risk assessment. So if there is any risk that seasonal variations could have an impact on your temperature controlled environments, well, then you need to perform seasonal mappings. Seasonal mappings, in my perspective, is not the requirement. The requirement is to perform a risk assessment. And in most cases where you have warehouses or containers or shipment containers that are exposed to outside environments, you do run the risk of seasonal changes having an impact. If we're talking about units like fridges, freezers, or cold rooms that are installed inside buildings with temperature control, those will most likely not be affected by seasonal changes, and therefore winter mappings and summer mappings are really not needed. You do though need a thorough risk assessment in which you qualify what the different impacts could be. It does also, when we've decided that we need to do a winter mapping or a summer mapping in that sense, it does also have an impact on where you place the sensors. And that's to a large degree a lot of the questions we get. How do we place sensors so that we cover the different risk areas? And we'll go through that today. Because there are some certain items that you could be considering when placing for a winter mapping. There's also a consideration in terms of whether you choose an ongoing verification or ongoing validation versus one-off mappings. And what do we mean by that? So traditionally, mappings are performed at a certain frequency or after major changes, and initially also during summer and winter. But there is actually the opportunity to do ongoing validation. It's not something that we'll cover in this webinar, but it's important to note that there is the opportunity to install more sensors that you would normally install during a constant monitoring, and thereby actually performing an ongoing validation on a day-to-day basis. Based on that, there's less requirements, or there's less cost associated with having personnel on site to install and retract the loggers, filling in reports and so forth, because you do have the constant confirmation that the stability and homogeneity of temperatures is within your requirements. It's a whole other topic, and I think we'll deep dive into that in later webinars. It's definitely an interesting topic. Winter mappings do also pose a challenge, one could say, in terms of defining the type and the extent of the testing scope. So what is the testing scope? The testing scope is basically what extent of testing do we need to perform during mappings. That could be in terms of duration. It can be in terms of the different types of tests to perform. And often that is something that's related to another topic, which is when is winter, and we'll get into those considerations in just a short while. So what kind of considerations should you basically take into account? First of all, as we mentioned before, when is winter? When is it coldest? The winter that you were experiencing during your mapping study, is that representative of all winters that you'll get until the next mapping? You should be considering cold surfaces and conduction and heat surfaces as well, as we'll get into. Of course, as well, outside air temperature just play a role. If you have gates or doors that are open to the external environment, those will also have an impact in terms of how you should be performing your study and how you should risk assess your operation. There's HVAC system performance, which kind of either heating or temperature control or cooling or both should you have in place in order to ensure optimal performance, as well as looking at whether the system performance will have an impact on your mapping studies, as well as low insulated areas. Do you have areas which are not as well insulated as the rest? That is a risk that we need to cover. And all of these items will go through in just a short while. And then lastly, of course, almost lastly, do we have products that we need to equalize in temperature? Do they have a lower temperature? And that goes exactly the same for summer mappings. Do we have products which come in at a different temperature than is specified at the acceptance levels? And then lastly, we'll take a look at sensor placements. So that is really the key in terms of managing these risks and finding out whether your system can actually perform under these various conditions. So the first question, as I mentioned, when is winter? Winter can be a multitude of different things. Of course, the item that we're most interested in is surrounding temperature. So this is a standard mean temperature scale or temperature graph from Copenhagen, Denmark, where our main offices are. And as you can see, there are certainly areas where it's generally colder. But when we are conducting a mapping study, that is often done during a period of, let's say, 1, maybe 2 weeks for larger facilities. And for smaller units, it might be as low as 1 or 2 days. So how do we ensure that we capture representative temperatures? And it's really hard to answer that question because you do not know whether that will be representative of all the cold winters that we have. A good rule of thumb is that if you stay within 5 degrees of what you expect to be your lowest temperature, that should pretty much cover all the different scenarios that you would expect during a year. But again, it's about risk appetite, and it's about having a well understood risk assessment. I should mention though that often when we perform a mapping study, we will get information to let us know where the hottest and the coldest spots are. And often when we perform winter mappings, it's the coldest spots that are really prevalent. Those will, to a large degree, still be the coldest spots, independent on whether it's cold or really cold outside. So in other words, do we have the coldest temperature outside? Well, it might not matter that much, because when we define a cold spot, for example, we'll place a constant temperature monitoring sensor there. And then subsequently, during our constant monitoring, we can see whether we go outside those limits. The cold and the hot spots are basically means in order to say us where is it coldest, where is it hottest, and all other temperatures should, to a high degree of certainty, be within those two. So as long as we follow it up with constant monitoring in the coldest spot, it should not matter that much if your outside temperatures drop below those limits. Yes, another really important factor are heat surfaces. So you might say heat surfaces, Jacob. Why is that important during a winter study? Well, most temperature control systems use a mixture between air conditioning, which can only cool, and then radiators. So one really key important knowledge you should have here is how does heat transfer. So there are three types of heat transfer. There's convection, which is basically when you have a hot surface, you will have air that's heated up, and that will rise with the temperature, which means often that if you have a radiator, you will have higher temperatures just above the radiator. Another part is conduction. We don't often see conduction in mappings, but basically if you touch something and it transfers heat, that's conduction. And then we have a really hidden risk here, which is radiation. So whenever we have a radiator and it's heating up, it will basically radiate with to the human eye invisible light towards the surrounding air. That means not only does the air increase in temperature, but products that are placed close to the radiator will also experience this radiation heat. And we do see, unfortunately, a lot of cases where you find non-conforming temperatures because you have product placements too close in front of radiators. Often the air is sort of understood that it moves around and heats the general space, but radiation heating is really one of the items that can cause nonconformities. So another part is again external influences, and the external influences are of course that the general air temperature outside is lower during the winter than it is during the summer. So one of the things that is often not or missed is, first of all, wind. We often see that if you have doors and gates to the outside that are not shielded by some sort of wall or alike, you can have wind blowing into the building, and that will cause really rapid temperature drops. Those temperature drops can be significant compared to when you have a summer mapping, where at least in Denmark does not often blow that much. The other part is the sun. So even though, and this is a good picture of it, even though that it is cold outside, when the sun hits surfaces, it really depends on whether those surfaces are facing the sun. And as the angle of the sun changes from winter to summer, it can be in different areas. It's often not something that we see have a huge impact though. So, but it's still something that's worth keeping in mind, especially also if you have windows, for example, that are not shielded properly. And again, of course, you have lower ambient temperatures. So when you open doors and gates, you will have an inrush of temperature of air that might not have conformant temperatures. So that's still something to be cautious about. Thirdly, product temperature. So even though often sensitive products are, of course, kept at controlled temperatures, in cases where you have mixed environments, so you might have controlled environments that are somehow linked or in the same space as non-controlled environments, if you bring in large quantities of cold products during the winter or hot products during the summer, those can actually have a significant impact on the general temperature of your warehouse, or often not fridges and freezers. Those are normally confined to sensitive products. But a large inrush of products that will then take up a lot of the heat from the room can actually have an enormous impact. And that's really something you can only take care of during the performance qualification, because during normal operational qualification, you often don't have influx, outflux of products. But that really means that when we design our studies, we need to ask ourselves, do normal operation include the influx or the loading or unloading of non-temperature controlled goods? Because then we need to test that as well, or at least have really good risk assessments in place to ensure that we mitigate those risks. Doors and gates. We often see cases where a summer mapping is performed and there are little to no deviations in temperature. It's performing really, really well. And then when we get to, because we have an ambient storage, for example, between 15 and 25 degrees Celsius. And then when we get to winter, we start seeing irregularities. And that sometimes can be traced back to having doors and gates that do not have either the proper insulation when they're closed. So you might have an influx of cold air through doors and gates. But what we see more of is cases where doors and gates do not have automatic closing on. So if your doors and gates do not have any sort of mechanism that ensures that they are closed, or if there is not a culture that you remember to close doors and gates, that can really have an impact that you could otherwise not see during summer mappings. So you might see irregularities and say, where did they come from? But often it's because those sort of influences are invisible during the summer, where the outside air temperature might be the same as that of the acceptance criteria or the acceptance levels. So basically, it's supposed to be 20 degrees inside, and it is as well outside. We often see it because there'll often be personnel working during the daytime where it's nice and hot, but not during the night where temperatures are non-conformant. But during the winters, we can often see this as an issue. So deep diving into sort of what should we do in terms of this outside air temperature? How does it affect our methodologies? So one thing where it can be very prevalent is in terms of power failure studies. So as I said before, when we perform power failure studies of ambient storages, for example, during summertime, it's often that we can't see it really having an impact because the outside air temperature is within limits. So no matter how long time we waited, we would never get to a non-conformant level. But during winter times, we can see that those temperatures will tend to drop, of course, due to the system having a power failure. So that is really something you should consider during a winter mapping. Power failure studies will often give issues for ambient storage. But then again, on the other side, for cold storage, you might not have the same type of impact. So that is really something where your test scope or test methodology is changed according to seasonality. Another part, as we talked about before, door opening studies. If we have doors and gates that are regularly opened, those are really dependent on the outside air temperature. And that also leads us back to when is it winter? So when you do door opening studies, you really want to test in worst case scenarios. And that's, again, I talked about before, the hot and cold spots. But basically, those are normally observed during stability studies. So that's studies where no one is entering or leaving the facility. But you should really design your door opening studies and the impact that it has in a way that you gather information during really cold areas of your season. Also, don't forget to put some questions in. That there's always some good questions along the way. Moving on to HVAC system performance. So one of the key elements to having non-uniform temperatures, which is basically what we're looking for, are cold and heat sources. So again, as I talked about before, you could either have systems that can only cool or systems that can only heat, or a mixture of those two. But it's really, really important to have a good understanding of where those are and where they either blow out air or where they radiate their heat to and from. So in the picture I have here, which is an imaginary warehouse, we have 3 HVAC systems that blow out temperature controlled air, and we have a radiator. So any type of heat or cold source is a risk that needs to be covered. And we need to be aware of which direction the air is being blown, or where it's radiated, or where that heat travels. So in the case above here, we need to take those risks into account and change our mapping protocol and methodology accordingly. Another thing we see often here is lowly insulated areas, and that could either be because you have differences in how the building is built or how it's constructed, but it can also be due to insulation degradation. So one of the more obvious cases is around doors and gates, where you have contact surfaces that degenerate over time. But you also do have a degeneration of walls and floors and ceilings, where it's very important to find out whether that's a risk, and if you get data that it is a risk, act on it. It's not always that we can act on poorly insulated areas, but it is one of the things we need to keep in mind, that if we have transitions from different building elements, or we have doors and gates, windows, those areas will often be less insulated than other areas. Yeah. As I said before about equalizing product temperatures, that's really one of the operational risks, and we'll get into risk categorization in just a short while. Again, if you have, there are basically 2 scenarios in which equalizing product temperatures is relevant. One is, as I mentioned before, if you have areas where you have non-sensitive products that you bring in and out, which can bring in a lot of cold. We've already discussed that. But secondly, when you have areas that are designed for equalizing product temperature or bringing them up or bringing them down in temperature, those areas will be highly affected by the volume and the mass of product that you are bringing into a facility. So one of the key scenarios where we see, for example, is when you have phase change material. So if you have packing boxes where you use phase change material in order to keep the temperature, you will bring in a lot of non-controlled products or phase change material packages, and you will try to get those down in temperature or get those up in temperature. And it really, really depends on the amount of packages that you try to equalize. So there's a question here from Smilja. Thank you very much. So to measure throughout the winter mapping period, what is the minimum measurement frequency of one data point in minutes? So it's a really good question in terms of how fast should we measure. I would often say that there is a maximum measurement frequency, or no, it's a frequency. So most of the guidelines outline 15 minutes as the sort of maximum measurement interval. But we would always recommend going for a maximum of 5 minutes. And why is that the case? Well, there are different scenarios where that play into role. So the main concern when choosing a measurement frequency is basically if you measure too slowly, you'll miss a lot of the peaks and valleys of your data. Let's say we took it to this extreme and we would only measure once per hour. You could basically have opened a door, let in a lot of non-conformant air, and then close it again, and you would not get that information. When you start to get below 10 minutes, preferably 5 minutes, you pretty much get all of the information that is both valid for when you're doing stability studies and when you're doing very fast events, such as door openings and so on. For stability studies, where we'll just try to measure for a period of time whether the general temperatures are within levels, and during power failures, those events are normally very quote unquote slow. So often you can get away with a measurement interval of, let's say, 15 minutes. But we would always advise on just choosing 5 minutes or below, because it's very easy to set up the systems, both ours and other systems on the market, to measure below 5 minutes. But a very good question.
Just to comment a bit on it as well, Jakob, because I'm guessing you can also look into different elements of it in relation to, like, if you are having a large scale warehouse where the your high and low acceptance criteria is a larger scope for it, compared to having a small equipment where it might only be a few degrees that you can actually do up and down. I guess that also has an impact in terms of how often do you actually want to measure the temperature.
And that's another really good point. Yeah. So one of thank you for that, Mads, as well. I almost forgot. So one of the elements as well in terms of how often you should measure is also based on the product size. So there's a very large difference between measuring small vials with vaccines, for example, up until storing very large packages of product. So in general, the smaller the packages, the more rapid you need to measure in order to get all of those smaller variations in. But there are other things that come into play as well, such as sensor performance, then the sensor you're using, how fast does that respond to temperature changes. So definitely is one of those key elements to be aware of. But as a rule of thumb, again, I would always advise on just choosing 5 minutes and below. It's very rare that isn't sufficient. But thank you very much. So there's another question as well here from Panas. In which part of the winter mapping process can we ensure that the maximum storage capacity is defined, particularly for items requiring a cold chain, to determine the highest quantity that can be stored in that space? Really good question, and it really it really digs down into one of the core elements of temperature mapping, which is you really need to, you can either, let me put it this way. You can either use a mapping to confirm that, in this case, the highest quantity that is possible within the acceptance levels, or the other approach is saying, we know we have these acceptance levels, how much can we fill in before we start to fail? So we would normally always advise on, if we're talking smaller units, try to find out like a fridges and freezers or cold rooms for like less than 50 square meters. Define what you need and try to see if that can be handled within the acceptance criteria. For larger warehouses, it can be a more cumbersome process to fill up the space and then performing the mappings. There's a lot of different guidelines, especially in the ISP guidelines for temperature controlled environments, where filling up parts of your warehouse and testing on a certain filling capacity, so let's say like 80% full, and seeing whether that is still within the acceptance levels. So what a mistake that we often see is that the guidelines will often say you need to perform empty and full studies. That is not entirely accurate. So empty studies, for example, if you have an entirely empty fridge, well, then there are no products in there. Then there is nothing to measure on. So basically, it should be called minimal and maximum loading. So minimal, of course, it should be very close to 0% without any product. But maximum loading should be defined in your requirements. So how much let's say in percentage, do you plan to fill your fridge at maximum capacity? And that is the maximum loading scenario you should be using. And the exact same thing with warehouses. How much of the shelf do you expect to be full when you're at max capacity? It's very rare that is 100%. It's more likely that it's somewhere between 80 and 90%. But it's really good question. And in terms of when, we would normally say that that's during the performance qualification. Yeah. Thank you very much for those questions. We'll try to move a bit ahead here. So we now have a lot of considerations to take into account. And how do we take them into account? Well, we place sensors in order to measure at those specific both scenarios and placements. We've developed here at GxP our own risk-based model in terms of defining what kind of risks are there and how do you plan to measure to mitigate those risks. So we define it as both compliance risk. Those are risks associated with not following some guidelines or standards on the topic. Often the guidelines, especially the WHO standards, are very thorough in the number of data loggers that you need to place. If you were to follow that, it will be several thousand data loggers for warehouse, and that's really not feasible. So that is a risk you're not following. You should be prepared to answer any auditor's questions in terms of why did you not follow the standard. Secondly, we have technical risks, and we've been through a lot of those. So those are stuff like radiators or HVAC systems. Where is the air coming from? Where does it radiate? Doors, gates, the forklift chargers, windows, insulation, that sort of stuff. So those are all risks associated with how the building is built, or the cold room, or the fridge or freezer is built, just inherently in the way the design is. And then lastly, we have operational risks. So those are some of the risks that we've talked about with equalizing product temperature, or opening and closing doors and gates, power failures, people entering and leaving, and so forth. So one of the things that the standards and guidelines don't really use a lot of time in explaining really, really well is that if you want to handle risk and handle it in a risk-based approach, you need to understand the underlying risks. So most of the standards and guidelines out there, those will propose what I would call rules of thumb. So you should place sensors in the corners and in the middle and near gates and doors, but they don't do a great deal in explaining why that is. So this is our risk model as well that we've developed here. So there's a series of questions here in terms of when we have a standard saying, for example, you should place sensors at the corners and center, they are actually saying that there is a risk that the temperature is not homogeneous and stable at all points. So when you understand the risk that temperatures might not be the same in the volume at all places, you understand, well, then I need to place sensors at those positions. And equally, they will say, oh, you need to place sensors near walls, like exterior walls and doors. Well, it's because we might have an external influence. That is the risk that you need to define and assess. We need to have placements near HVAC systems. Well, it's again because we might have non-conformant temperature air blow out from the HVAC system, or we might have heat radiated from radiators. So again, we need to understand the underlying risk. We need to have placement near control sensors. Well, it might be because we don't have an optimal control sensor or non-calibrated control sensor. So when we set it to 20 degrees, the control sensor might see an entirely different temperature and try to control a temperature according to that. And then lastly, as I mentioned before, we have placement near heat or cold sources. So that could be walls, gates, windows, poorly insulated areas, forklift chargers, and so forth. Well, it's because there's a local heat or cold zone or radiation. So let's just see. We're actually getting a lot of questions in here. We'll try to take some of them. So we have a question here from Leon saying, when mapping equipment such as upright freezers with dynamic cooling systems, is it acceptable to use dampeners like glycol glycerin to counter sudden wind chill spikes from airflow? That is a really well debated question whether dampeners are acceptable. So basically, we need to remember then when we place a data logger in a fridge, freezer, warehouse, whatever it might be, or temperature controlled container, what we're actually trying to achieve is actually measure whether that has an impact on the product. So in the best case, we would measure the temperature of the product. That is actually what we're looking for, but in all cases, the air temperature will change before the product temperature does. So in that case, you will have less spikes when you use a dampener. So if you don't know what a dampener is, you could take a jar or a vial of let's say glycol and insert the sensor into that. It will take some time. If it gets hotter, it will take some time before the heat is transmitted into and conducted into the vial, and therefore changing the temperature. It really depends on how your risk appetite is. If you don't use dampeners and you have these spikes and you write your report, you need to justify that the product temperature did not change as much as the air temperature. So I'm sorry for not giving a yes or no answer, but basically, if you don't need dampeners, you would probably need to be able to justify why air temperature changed without product temperature, and vice versa. If you use dampeners, you need to be able to justify and have the knowledge that the dampening of the temperature sensor is very similar to what the product temperature is. So it's two different kinds of knowledge that you need to have. So there were some other questions as well. So a question here from Sami saying, our Ministry of Health inspectors think the reason for thermal mapping is to accurately place the temperature monitors, which does not make sense for me other than providing that the warehouse are qualified for storing within specific limits for our products, which are below 30 degrees according to USP. So I'm sorry, Sami, but I actually tend to agree with your health inspectors. What we haven't really touched base on today is really the purpose of temperature mapping, and there are several purposes. So you are also right, in my view at least. Thermal mapping is used to confirm that the unit, or whatever size it may be, can operate so that the environment within it is within the acceptable limits. That's one key point. That is absolutely correct. But the other output we should have from a mapping study is also to know where should we place sensors so that we will the fastest find out if we have temperatures outside the acceptable limits during operation. So to take an example, we would often during a study find out that there's a corner where it's the hottest normally and one where it's the coldest normally. So if we place two sensors at those positions, we should, with a reasonable degree of certainty, be assured that all other temperatures are within those 2 points. So if something happens and everything gets hotter at the same time, the hottest spot we found during the mapping should be the first place where we would be able to measure a higher temperature. And therefore, it's really a matter of placing temperature sensors where we'll get the first indication that temperatures are outside acceptable ranges. So another output we often get is that we find, okay, during a power failure study, which area is affected first? So let's say you do have a power failure, and the spot that we found out during the mapping study is the one that gets hottest the first. If that is within limits when we restore power to the system, well, then we can reasonably say that all other temperatures also should be within those limits. So we avoid a lot of having to deal with nonconformities or incidents and throw away product. You raised a really good question, was actually that your requirement is basically that it needs to be below 30. And in that case, it really doesn't make a whole lot of sense when we take the risk-based approach to have a sensor in the cold spot. Because the same thing goes for ultra low temperature freezers, for example, ULT freezers, normally operating at, let's say, minus 70 degrees Celsius, and fridges operating where it just needs to be below minus 20 degrees Celsius. It only makes sense to find the hotspot, because whether it's minus 25 or minus 30 or whatever, it doesn't matter for the efficacy of the product. Really good question. I'll just take one more point because I can see some of the questions are really related to this one. So again, remember what we went through. We have compliance risk, technical risk, and operational risks. So if we take this image of a typical warehouse and we apply all of the different considerations, we would now have a lot of different candidates for what sort of test should we run and where should we place our sensors in this. So just taking this an example, we know that there are risks associated with doors and gates both during summer and winter mapping. So we should place sensors there. We know that there are risks associated with the temperature control system, so we should place sensors there. We might have operational risks. So where do we load in products into the facility, and where do we unload them again, and where are they placed in the meantime until they get to shelving? That is a place we should take into account. We have forklift chargers, which is a technical installation or technical risk. We should place sensors near those to ensure that those do not affect product. And understanding all of these different items and then applying them to sensor placement, it actually gets a whole lot easier. I at least hope you could use some of the different items we've discovered here. So we'll just take some of the questions here. There's some great questions. Leon has a question here. When mapping a large area, is it acceptable to do several mappings covering demarked sections of the area, one section at a time? Really good question. Yes and no. You should have a high degree of certainty that the unit would operate in the same way when doing smaller section at a time. It is accepted. We've done it with customers before, and it has been accepted by regulatory bodies and auditors. When doing smaller segments at a time, you should be cautious about how do you define the hot and cold spots, though, because when you do place sensors in the entirety of the volume at the same time, you will have measurements that are very comparable. So the measurements will be comparable to each other. Whilst when you do it in smaller segments, there is the chance that due to external variations, due to difference in how you do your door opening and power failure studies, or loading and unloading, that could have an influence. Because one section of temperature mapping, one part of it is doing in absolute measurements. So in absolute, the temperature within. But another part of it is basically doing relative measurements. So how do the different temperature points and the measurement points compare to each other? And that is one of the things to keep in mind. But yes, it is possible. So another question here from Sama saying, could you please explain power failure test and door opening test for warehouse during winter mapping? Yeah, I could. So power failure test is the the easiest one to explain, I would think. So if there is a risk, and again, we would always encourage to apply a risk-based approach. If there is a significant, it depends on your risk appetite, significant risk that power could be out, and it's not only power, it could also be a temperature control system failure. It's not always that those two go hand in hand, but in general, we call it power failure studies. You basically turn off your temperature control system and see what happens. How long time does it take for temperatures to get non-conformant? And I did like this, should probably done like this for winter mappings. But it's just a matter of finding out how long time do you have before you need to be back online. And door opening tests are basically where you define what do you expect in terms of the amount of door openings, not only doors, but also gates, unloadings, do you expect to have during a normal working day, for example. And then you simulate that. So if, let's say, you plan to open 20 times a day for 10 minutes each, well, then that would be roughly once an hour or once every half an hour. And then you basically simulate this. You open the doors, 10 minutes, close them, wait half an hour, open the doors, close them, wait half an hour, and so forth. And then you see the effects of those door openings on the temperatures within your warehouse. And the same thing goes for temperature control trailers. How often do you plan to open them? Is it a one route connection you're planning to test for? So being loaded one place, going one other place and offloading, or is it dropping off products at smaller stations? Well, in that case, you need to ensure that when you open and close the doors, that temperatures go back to normal within a certain specified amount of time. And the same thing goes for fridges and freezers. I'll just move a little bit ahead because we're getting to the end of here. So lastly, again, when we talked about this sensor placement, we're still yet to talk about the amount of testing and the scope of testing. So a lot of these questions basically answered that question. But then again, remember that different scenarios should match what your expected operation of the facility is. So that goes for both power failures. And I forgot to mention as well that if you have a power backup system, well, the chances of your temperature control system failing might be less than not. So you still need to evaluate your risk appetite. And then again, door openings, both doors to the outside, gates to the outside, but also internal doors between office buildings where you might have different temperature. Yeah. So now we have a questions and answers, and we're really warming up here on these. So let's just continue a bit. So there's a question from Patricia here asking, how accurate can we be in doing a loaded study on a trailer when there are infinite possibilities for load configuration? So how do we? Great question, and we've had this with several customers. So one key approach to this is basically thinking about worst case scenarios, right? So I'm expecting, Patricia, you're talking about contain or trailers where there could be two different temperature zones, for example. I know, hopefully you can confirm it. So the worst case is often when there's different worst case to take into account. One is where the control temperature, so the temperature you want to achieve, is the furthest from the outside air temperature. And another one is where the two compartments have the largest difference between them. And then again, often in these trailers, you can move the separator forth and back in order to create different volumes. We would often advise on doing a test where you have the hottest setting on one side and the coldest on the other side. And during that study, having it all, doing that as one study with the separator in the middle, and then one where it's all the way to the right or left, and one where it's all the way the other way around. That comes down to basically 3 tests. But yes, there is an almost infinite amount of possibilities, but it's really trying to figure out what of these scenarios is the worst case. We often like to draw a matrix of all these different scenarios with customers when we do trailer mappings, because we perform a lot of those as well, and find out in which of these cases is it worst case, where's the greatest risk. And that is both in terms of outside air temperature, so that would be summer, winter, but also in terms of the dual zone. I hope that answered your question at least, but it's a great question because you can really dive into the rabbit hole. So yeah, one of the last questions we'll have time for here. There's really a lot of questions. Thank you for that. Sammy asks, if I have the effect of hot and cold air infected my warehouse, which is the difference between higher and lower position, when I place the logger between plus minus 2 degrees, how to define the hot and cold spots? Great question, and I could use an entire webinar talking about hot and cold spots. So I would really also advise watching some of our previous webinars, but there are several ways to define hot and cold spots. One is through like the average temperature. You could use peak temperature. We often like to use a combination of those. What we often see, though, in a realistic scenario, especially if we're talking larger volumes, is that you will have areas that are generally hotter and areas which are generally colder. And sometimes you have several hot, we call them hotspot candidates or cold spot candidates. So you might have 3 corners or 3 places where it's hottest. Well, the approach is basically to place sensors in each of those. And often that is also not a major difference in terms of how many sensors you would otherwise place. Yeah, I think that was really all of the questions. So thank you very much. I think I'll hand it over to Frederikke as well and Mads to see if there are any sort of closing remarks. So I'll hand it over to you, Frederikke. Yeah.
There we go. Hi. Well, just a closing remark. Thank you so much for an excellent webinar, Jakob and Mads. And thank you for the great questions. We really love to deep dive into this Q&A session, as you can probably feel on Jakob especially. So yeah, just as I mentioned right in the beginning, if you have any questions or concerns about your upcoming mapping projects and operations, just feel free to let us know. I'll reshare the link where you can schedule a session with Mads, and then we'll be in contact if you need any assistance or guidance. We're here to help you out. I shared some links on different other mapping webinars that we've made previously, also with Jakob and Mads, I believe. And yeah, feel free to check them out. They're all free and on demand on our website. And yeah, there's a lot of good stuff to check out.
Absolutely. Thank you very much, everyone.
Thank you.
Hello.